So, good morning class. Today we will discuss some of the reactions which are shown by phenols and they are different from that of alcohols. So, these reactions are just different or opposite to that of alcohols, because in case of phenols we have to discuss two type of reactions. One are the reactions which are same to that of alcohols and the other are the reactions which are different from that of alcohols. So, reactions of phenols which are different from that of alcohols, which are different from that of alcohols, which are different from that of alcohols. So, these are the reactions of phenols which are different from that of alcohols. So, in this case we will discuss some 14 reactions. The first reaction which we have to discuss is halogenation, that is addition of halogens, and this halogenation, that is addition of halogen atom, is most widely studied in case of bromination. So, we will study bromination of phenols. So, while discussing bromination of phenols, so if there are two mechanisms of bromination, like if this is phenol, when it is treated with 3 molecules of bromine, then what happens? 2,4,6 substitution takes place and leads to the formation of 2,4,6 tribromophenol plus 3 molecules of HBr. So, this is 2,4,6 tribromophenol. And this is the first mechanism. Now, let us see the second mechanism of bromination. So, in second mechanism of bromination, when phenol, this is phenol, when phenol is treated with bromine, in the case of a weak inert solvent, that is carbon disulfide, then it leads to the formation of two products, that is ortho derivative and para derivative. So, this is orthobromophenol and this is parabromophenol. So, this is the entire mechanism of bromination. There are two mechanisms of bromination of phenols. So, there are two mechanisms of bromination of phenols. In the first mechanism, when phenol is treated with 3 molecules of bromine, it leads to the formation of 2,4,6 triderivative product and leads to the formation of 2,4,6 tribromophenol, and 3 molecules of HBr are also eliminated. But when phenol, this was the first mechanism. In the second mechanism, when phenol is treated with bromine, in the case of inert solvent, that is carbon disulfide, it leads to the formation of ortho and para derivative products. So, orthobromophenol and parabromophenol are formed as the two products, and this parabromophenol is the major product which is more stable. So, this is the major product and it is more stable. So, these are the two mechanisms involved in the process of halogenation. Now, let us see the second case of nitration. Now, let us see the second case of nitration. The next process of nitration. So, this process of nitration is further of three mechanisms. It has three mechanisms. So, let us see the first mechanism. Let us see the first mechanism. So, in the first mechanism, when phenol is treated with dilute nitric acid, it forms two derivative products, that is ortho derivative and para derivative, ortho derivative and para derivative. So, this is orthonitrophenol and that one is paranitrophenol. So, this is the first mechanism of nitration. When phenol is treated with dilute nitric acid, it leads to the formation of ortho and para derivative products. So, this is orthonitrophenol and this is paranitrophenol. In the second mechanism, when phenol is treated with concentrated nitric acid and concentrated sulfuric acid. So, 2,4,6 substitution takes place and it leads to the formation of 2,4,6 nitrophenol. Its IPC nomenclature is 2,4,6 trinitrophenol, or it is commonly called picric acid. It is commonly called picric acid. So, in the second mechanism of nitration, when phenol is treated with concentrated nitric acid and concentrated sulfuric acid, so 2,4,6 substitution takes place by nitro group and leads to the formation of 2,4,6 trinitrophenol, or it is commonly called picric acid, and this picric acid is highly explosive in nature. And in the third mechanism, when phenol is treated with concentrated sulfuric acid, so it leads to the formation of two intermediate compounds. This is orthophenol sulfonic acid and this is paraphenol sulfonic acid, and on further treatment of this compound with concentrated sulfuric acid, it leads to the formation of picric acid again. Again 2,4,6 trinitrophenol is formed, which is commonly called picric acid. So, these are the three mechanisms of nitration of phenols. This is first mechanism, second mechanism and third mechanism. In the first mechanism, when phenol is treated with dilute nitric acid, it leads to the formation of two derivative products, that is orthonitrophenol and paranitrophenol. In the second case, when phenol is treated with concentrated nitric acid and concentrated sulfuric acid, then 2,4,6 substitution takes place and leads to the formation of 2,4,6 trinitrophenol, which is commonly called picric acid. And in the last mechanism, third mechanism, when phenol is treated with concentrated sulfuric acid, then orthophenol sulfonic acid and paraphenol sulfonic acid are formed, which on further treatment with concentrated nitric acid leads to the formation of picric acid, or which is also called 2,4,6 trinitrophenol and commonly called picric acid. Now let us come to third reaction, that is sulfonation. Let us come to third reaction, that is sulfonation. That is addition of sulfonyl group. Now, in this reaction we will introduce SO3H group, which is called sulfonyl group. So, in the case of sulfonation, there are two mechanisms. This is phenol and there are two mechanisms of sulfonation of phenols. First is when it is treated with concentrated sulfuric acid at 293 Kelvin, and the second is when it is treated with concentrated sulfuric acid at 373 Kelvin. So, when it is treated with phenol, when phenol is treated with concentrated sulfuric acid at 293 Kelvin, then ortho derivative is the most stable product, that is OH, and attachment of SO3H group at ortho position leading to the formation of orthophenol sulfonic acid and when it is treated with, when phenol is treated with concentrated sulfuric acid at 373 Kelvin, it leads to the formation of para derivative and the compound formed is called paraphenol sulfonic acid. Paraphenol sulfonic acid. So, these are the two mechanisms of phenol or sulfonation of phenols. When phenol is treated with concentrated sulfuric acid at 293 Kelvin, it leads to the formation of orthophenol sulfonic acid. But when phenol is treated with concentrated sulfuric acid at 373 Kelvin, it leads to the formation of para derivative and paraphenol sulfonic acid is formed. So, this is stable at lower temperature, that is 293 Kelvin, and this compound is stable at higher temperature, that is 373 Kelvin. Now, the fourth reaction is Friedel-Crafts alkylation and acylation. Friedel-Crafts alkylation and acylation. So, we have to discuss both the process, that is alkylation and acylation. So, let us see the first case of alkylation. So, when phenol, this is phenol, when phenol is treated with idomethane, that is CH3I. So, this HI is eliminated and the reaction takes place in the presence of aluminum chloride minus HI, this is idomethane, leads to the formation of this CH3 group would be attached over here, leading to the formation of OCH3, and this is a ether called methyl phenyl ether, called methyl phenyl ether, or it is commonly called anisole. And the second process is of acylation, introduction of acyl group. So, in the case of acylation, when phenol is treated with acid chloride, that is ClCOCH3, this is acetyl chloride, and when the reaction takes place in the presence of aluminum chloride AlCl3, what happens? This HCl is again eliminated minus HCl, and this group is attached over here, and this is COCH3, and this is called acetoxybenzene. So, this is the overall reaction of Friedel-Crafts alkylation and acylation. So, first is the process of alkylation, introduction of alkyl group. When phenol is treated with idomethane, this HI is eliminated and the reaction takes place in the presence of AlCl3, aluminum chloride, and this CH3 is attached over here, leading to the formation of methyl phenyl ether, or it is commonly called anisole because it is a ether. And in the next reaction, when phenol is treated with acetyl chloride, this HCl is eliminated and this acyl group, that is COCH3 group, is attached to this oxygen atom, leading to the formation of acetoxybenzene. Now, let us see the fifth reaction. Let us see the fifth reaction. That is Gattermann reaction. Gattermann reaction. This is the next reaction. So, when phenol, this is phenol, when phenol is treated with HCN plus HCl in the presence of anhydrous zinc chloride. So, water molecule is eliminated and it leads to the formation of a intermediate compound, that is CN double bond NH, which on further oxidation in presence of H plus ion yields salicylaldehyde. This is salicylaldehyde. So, this is the complete Gattermann reaction. First of all, when phenol is treated with HCl in the presence of anhydrous zinc chloride, so water molecule is eliminated and an intermediate compound is formed, wherein carbon nitrogen is doubly bonded with NH group, and it on further oxidation in presence of H plus ion, it yields CHO group over here, and this entire compound is called salicylaldehyde. This entire compound is called salicylaldehyde. Now, let us come to next reaction, that is 14th reaction. We did see 13th reaction, that is Riemann-Diemann reaction, and then 14th reaction is Liebermann's test. This is Liebermann's test. So, in case of Liebermann test, this is phenol, it is treated with HONO, this is nitrous acid, this is nitrous acid, in the presence of sodium nitrite and sulfuric acid. So, what will happen? A water molecule will be eliminated and it leads to the formation of, here it will be OH group and here it will be NO group. It is called para-nitrosophenol. In the next reaction, this hydrogen displacement takes place and it comes over here, leading to the formation of oxim. This is oxen. In the next step, it is treated with, this oxen is treated with phenol, or let it should be like this. It is treated with phenol, and here it is hydrogen atom, we already know. So, this is phenol. So, this reaction is treated with concentrated sulfuric acid. So, water molecule will be eliminated because concentrated sulfuric acid is a dehydrating agent. So, what will happen? This is oxen, and this nitrogen atom, this water molecule will be eliminated. So, this is nitrogen atom, here it is already oxygen atom present, and it will be bonded directly to this phenyl group. Here it is OH, and this OH which is found, here it is double bond, and H2SO4 will be added. So, this will be single bonded, and arrangement of bisulfate ion over here. So, this compound is called indophenol hydrogen sulfate, indophenol hydrogen sulfate. In the next step, this indophenol is treated with water, then sulfuric acid molecule is eliminated. So, what will happen? What will happen? Nitrogen, phenyl ring, hydrogen will be eliminated from here. So, double bond oxygen, and here it will be OH, again double bond, double bond. So, this is indophenol. And finally, when it is treated with NaOH, so what happens? This hydrogen is substituted by Na group, this is sodium salt of indophenol. So, this is the complete mechanism of Lieberman test, which is also called Lieberman's nitroso test or nitroso reaction. So, first of all, what happens when phenol is treated with nitric acid in the presence of sodium nitrite, sulfuric acid? So, water molecule is eliminated, leading to the formation of para-nitrosophenol. Further, hydrogen shift takes place, leading to the formation of oxen. When it is treated with concentrated sulfuric acid, a water molecule is eliminated from here, and this group is attached over here to nitrogen atom,